Welcome to Lecture 4. Today we're going to talk a little bit about object technology. Objects, or more precisely as we'll see in Chapter 3, the classes objects come from are essentially reusable software components. There are data objects, time objects, audio objects, video objects, automobile objects, etc. Almost any noun can be reasonably represented as a software object in terms of attributes such as name, color, etc., and behaviors, what you do to these objects, calculating, moving, communicating. Now, find the nouns method of determining your objects has become a little obsolete because it's not quite enough, but it's a good place to start. Using a modular object-oriented design and implementation approach can make software development groups much more productive, and object-oriented programs are often easier to understand, correct, and modify. So let's start with an example. The automobile is an object. Suppose you want to drive a car and make it go faster by pressing its accelerator pedal. Before you can design a car, someone has to design it. A car typically begins as engineering drawings similar to blueprints. Drawings include the design for an accelerator pedal and how it works. The pedal hides from the driver the complex mechanisms that actually make the cars go faster. You don't have to worry about, internal combustion or anything like that. And the brake similarly hides slowing down mechanisms. That's called abstraction. This enables people with little or no knowledge of how engines work to use a car. Without that, you'd really have a hard time. Before you can drive a car, it must be built from the engineering drawings, and a completed car has actual accelerators and brakes, etc., to make them go faster. A car won't go on its own, so the driver must press the pedal, so that's an action that has to be taken. So, objects consist of functions, member functions, and classes, or object-oriented programming consists of. Performing a task in a program typically will require a member function or a function. Functions tend to house the program statements that actually perform tasks. They are subroutines. They hide these statements from the user, just as the accelerator pedal of a car hides it from the driver. In C++, we create a program unit called a class to house the set of functions we perform the class tasks. We also house the object's data, or the class's data. These functions are called member functions. A class is similar in concept to a car's engineering drawings. Essentially, it's a template. Instantiation creates an instance of a class, typically called an object. Just as someone has to build a car from its engineering drawings, before you can drive the car, you must build an object from a class, and that's called instantiation. And an object is an instance of a class, and that's how we refer to it. One of the key points with classes is classes are reusable. Think of a cookie cutter versus a cookie. A class is the cookie cutter, an object is the cookie. And reuse of existing cookie cutters, it saves a ton of time and effort. Reuse also helps you build more reliable and effective systems because we can reuse stuff we've used before that have been tested, debugged, and just tweaked to all day. And basically it gives us the notion of software interchangeable parts. Now, it doesn't quite work that well, but that's the idea at least. So when you drive a car, pressing its gas pedal sends a message to the car to move you faster. Similarly, you send a message to an object by calling a member function. Each message is implemented as a member function call. You say to the object, go do this, and it goes and does that. Attributes and data members. A car has attributes. Those are things that describe a car. Color, number of doors, gas tank, its odometer reading. The car attributes are represented as part of its design. They are what makes cars distinct objects as opposed to from the class of car. Every car maintains its own attributes. That's how you identify it. Each car knows how much gas it has, but not how much gas is in other tanks of other cars. An object has attributes that it carries along as it's used, and they're part of the object class. A bank account object has a balance attribute, and that's in the class, but the balance attribute instance would have the amount of money in a bank. Each bank knows the balance of every object in the account, but not the balances of other accounts. In C++, we specify attributes using what are called data members. Encapsulation wraps attributes and member functions into objects created from these classes. It creates a nice combined little package. Objects can communicate with each other. They're not allowed to know the details because the implementation is hidden, but you can communicate with the interfaces. Information hiding is crucial to good software engineering. Inheritance is this idea that a new class can be created conveniently from the characteristics of an existing class. For example, convertible would be inherited from car. Now, although everybody talks about inheritance in object-oriented programming like it's a big deal, it is often overused and it can be disastrous when you do. So, one way to develop programs is to use object-oriented analysis and design. How will you create the code? You file detailed analysis process in gathering project requirements, develop a design, carefully review the design. However, this methodology has mostly fallen out of favor and been replaced by something referred to as Agile software development. The UML is a modeling language for describing diagrams having to do with architecture and design of a system. And some of this is used, but not as much as you might think. So that's an overview to what object technology is, and I guarantee you we will be revisiting that in much more detail in the coming weeks.